These notes are on inverse relations. In Math 1 and in the previous video that has inverse relations review, we talked about how to find inverses and some relationships that some interesting things that we found with inverse relations. For now, we're going to talk about testing to see if two functions are inverses. So if two functions are inverses of each other, then g of f of x equals x equals f of g of x. So the composition of the two functions going in both directions has to equal x in order for the functions to be inverses. So let's look at an example. Say I have f of x equals 3x plus 1, and g of x equals x minus 1 over 3. I'm going to do both tests. F of g of x. So f function, plugging in the g function. I simplify again. And so I have f of g of x equals x. I have to do the other direction. G of f of x. So I take my g function and plug in my f function. And that also simplifies to be x. We say since f of g of x equals x, which also equals g of f of x, f of x and g of x are inverses of each other. So another interesting thing we can do with inverses is that if I take an x and plug it into a function, and then take that answer, that result, and plug it into the inverse of the function, I should end up with the same x. So let's use this example here and try that out. So let's say I have f of 3. So I plug f of 3 into, I plug 3 in for x in the f of x function, so 3 times 3 plus 1. Which equals 9 plus 1, 10. If I then take my 10 and plug that into my inverse function, I get 10 minus 1 over 3, which equals 9 over 3, which equals 3. And I can see here that my x's are the same. The last thing I want to talk about with inverse functions, and this is something that you looked at last year, but I just want to remind you that if I graph these two functions, so 3x plus 1 and x minus 1 divided by 3, and I'm going to change my window here because it's a little bit hard to see. I'm going to go to zoom and 6, meaning standard. And when I graph those two functions, we can see that there's a line of symmetry. That if I had graphed in here also y equals x, that would be the line of symmetry that would map the first function to the second or the second to the first.